CH what? Eh? Laplace transform. Please help me open advanced engineering mathematics or GEMBED. Both of them open it. So anytime I want to solve questions, I'll just collect it and solve questions. Laplace transform. So let me just give you a short note. Engine math, we don't actually need much story. So let me just give you short notes so that Laplace transform. Laplace transform deals with Laplace transform deals with changing of a function. Deals with changing of a function from its time domain t, from its time domain t, from its time domain t to its Laplace domain s, to its Laplace domain s, to its Laplace domain s. Full stop. Full stop. So what are you saying? You change a function from its time domain t to what? Laplace domain s. That's what you are doing. You understand? Full stop. Laplace function or Laplace transform, right? Laplace transform is very important to engineering problems. It's very important to engineering problems such as process control, comma, process optimization, etc. Full stop. As a chemical engineer, right? As a chemical engineer, it's very important. It's very important to know how to solve differential equations. Using Laplace transform method. Using Laplace transform method. So all the things you want to be doing here, you start with derivation of Laplace functions, all other things. At the end of the day, if you don't know how to use Laplace transform to solve differential equation, as a chemical engineer, you have not know anything in Laplace transform. You understand? Because normally, differential equations, it has its own method of solving questions on it. You understand? Here you have first order differential equations, second order differential equations, and higher order differential equations. So the first order differential equations, you know the method. There are like 4 methods. Can you get it? There are like 4 methods. You have the integration method, that is direct method. You have the homogeneous method, that is by substitution under normal differential equations. We have the linear method, That's what we call integrating factor. You get? And we have what we call Bernoulli method. So these are the methods we always use to solve differential equations. We also have separating the variable methods. So these are the methods used to solve first order differential equations. We also have second order differential equations. We have the methods. But easily, you can use Laplace transform to solve your differential equations. That's what they are trying to say. So instead of because if you want to consider all these methods, you have to know each particular method with a particular question. If you see a question in the differential equation, you have to know that, okay, this is the method I'm using for it. This is the method I'm using for it. But irrespective of the question that you have, you can just use one formula in Laplace to solve the question. You get what I'm trying to say? Are you following? Alright. Now, the first thing we are going to do, so because we are not going to jump direct to how to use Laplace transform to solve the differential equation, we are not going to jump. So we are going to start with, okay, what's the general formula of Laplace? That's the first thing you need to know. So full stop. Laplace transform is given by the general formula So we always use this symbol. You can use this symbol for Laplace. They are like 4 symbols. If you check Geometry, there are 4 symbols. But in your advanced English math, it's just one symbol they use. But in Geometry, we use 4 symbols. So if you read the introduction. Now, but this is the common one. You get? This is the common one. So the Laplace transform of the function of t is given by the formula integral of your time from 0 to infinity. Function of t exponential minus st dt. So this is the general formula you always use to get any function in its Laplace domain. So this also equals to, you can say this also equals to function of s. You can say function of s equals to Laplace function of t. It's the same thing. So if you are putting f of s direct, f of s, you don't need to put Laplace again. You don't need to put this symbol again. So the f of s is showing that everything is already in what? Laplace domain. You get? So for this one is telling you that, okay, you want to transfer the what? Laplace domain, the time domain into what? Laplace. So this one is still the same thing as what? As this. Which everything equals to what? This. Are you following? Please, if you have any question, you can always ask. You can gain from one another. Okay. So have you written the formula? Alright. Now the first one I will start with, I'm going to use this formula to derive them. And please, if I want to derive, I'll be integrating. So any integration that I'm doing that you don't understand, just call me back. So I want to start with, if I have a function in its time domain, which is a constant. Function which is what? Which is constant. Which is constant. Let's say A. In higher engineering mathematics they use A, but some other textbooks they use K. You understand? So any symbol, just make sure that it is constant. You can use A or you say K, anyone. Now I want to use A. So what will be the Laplace of any constant? Constant means like your numbers, like 1, 2, 3. You understand? So if I say what is Laplace of 3? What is Laplace of 4? They are constants, right? So I want to now derive the Laplace general formula for them from this. So from this general formula, I want to derive the Laplace general formula for constants. You understand? In case when you have 4 and they ask you what is the Laplace function of 4, you have 5. What is the Laplace function of 5? So from this place, just come back to this place. So just say Laplace of, what is your function of t? Your function of t here is your constant, which is what? A. Is that not? So it's like this A is like A t raised to power 0. You understand? Well, do not put it. Don't need it. Just say constant. So we have Laplace of a equals to integral from 0 to infinity of what's our function of t? A, right? Exponential what? Minus st the what? The t. Please, are you following? So instead of your function of t here, just put what? A. Now this a is like constant, abi? You know we are integrating 3x dx. You can bring the 3 out. Is that not? Like 3 integral of x the what? The x. Abi? So it's like a constant. So this a2 is a constant. So just take it out. So you have a integral of what? 0 to infinity exponential minus what? St the what? The t. So from this page, what will you do? Just integrate exponential what? Minus st. For your integration, what integral of e raised to power kt? What integral of e raised to power kt for your integration? No, I'm not putting minus. Just e raised to power kt on your integration. 1 over k, integration of what? Sorry, exponential what? Kt. Thank you. So it will be 1 over k exponential what? Kt. But if it is differentiation, what is the t of exponential kt? What will be the differentiation? K e raised to power kt. You understand? So the same thing. So if your what you call e raised to power kt, the integral is 1 over k exponential kt. It means what you are having is you are taking the what? The 1 over what is beside what? T. Abi? So the same thing here. What is beside t here? Minus s. Right? So you have a open bracket 1 over minus what? Minus s. Abi? Exponential. Just repeat the same thing. Minus st. So you put your limit 0 to what? Infinity. Please, are you following? Where do you have problem? From where? This one. Okay. I use this one to explain. If you are integrating your integration, these are constant integration. You understand? They are constant integration. Like if you have differentiation of sine t, differentiation of sine t is what? Cos t. Abi? The way is constant. Though you can derive it, but it always keep to our brain that anytime you want to differentiate sine t, it will what? Cos t. Right? You want to differentiate cos t, differentiation is what? Minus sine t. The same thing to this one. If you are differentiating exponential kt, it should be just this. Okay, just bring it at the back. Then repeat your exponential kt. That's just differentiation. But if you are integrating, that k will be at the denominator. It will not be at beside it like at the back. It will be exponential kt over k. It will not be here. So exponential kt over k is same thing as 1 over k exponential kt. Now the same thing now do here. So it means if I want to differentiate, okay, if I want to integrate exponential minus kt, it will be what? 1 over minus k, abi? Exponential minus kt. Still the same thing I do here. So exponential minus st, if you integrate is same thing as what? Minus 1 over what? S. So just repeat exponential minus st. Are you clear? Alright. So 0 to what? Infinity. Now, from this place, what we do? You instead of t, you put what? Infinity, and instead of t, you put what? 0. That's all. Then just have Laplace of a constant a equals to a into what? So you put this one, you're going to have minus 1 over s, abi? Or this minus, let me take it out. So let's say we have minus a like this. So you are now having 1 over s, right? Exponential minus s times what? What's the first t? What are you using? Infinity times infinity, right? Then what will you put? Minus. You all remember this, right? So we have minus 1 over what? S again. Exponential minus s times what? 0. Now, from this way we are going to have minus a. Look at this. Minus s is multiplying what? Is multiplying infinity. Now, if you have 3 over 0. 3 over 0 is what? It's infinity. It's infinity. Then 0 over 3 will be what? 0. So if you have a number dividing 0, it will give you what? Infinity, right? But if you are having 0 dividing a number, it will give you what? 0. So the same thing. If you are having what do you call a number multiplying infinity, you understand? It's still going to give you infinity. If you have a number multiplying infinity, it's still going to give you what? Infinity. Except it's what? 0. If it's not 0, any number multiplying infinity is just going to be what? Infinity. Now I want to show something. You know, if you are having all this one like this to be what? Infinity. It will now be infinity over what? Over s. Have you? Is that not? Infinity over s. And infinity over s, if a number or anything dividing 0 is infinity. Infinity dividing anything is also what? 0. That's opposite. Are you following? That's one way to understand it. Another way to understand it, and this one is the most common way to explain, is that anytime you are having an infinity multiplying anything, just take the limits. Just take the limits. So you just say, okay, you put it in your mind that, okay, when you take the limit of all this, you get, that is the lim of, what do you have here? S, have you? Tends to what? To 0. So just say, okay, when you take the limit of anything here, s here tends to 0, everything will be what? 0. You understand? That's another way. So anytime you are having infinity multiplying a Laplace domain, just take the limit of that s to be 0. When you take the limit to be 0, automatically everything is what? 0. Then minus 1 over s. What will be this one? S times 0. S times 0 is what? 0 now. So you have exponential minus 0. Exponential minus 0 is what? 1. And so the same thing as 1 over exponential 0, Abi. So which is exponential 0 is what? 1. So 1 over 1. So everything here is what? 1. Are you following me? So you have minus a into, so 0 here minus everything here, still the same thing as minus 1 over what? S. Abi. So minus times minus plus, you have a over what? S. So that means the Laplace of any constant will be what? Will be that number divided by what? S. So if they ask you what is the Laplace of 2, you just say 2 over S. What is the Laplace of 3? 3 over S. You get? So this is the expression for the Laplace of a constant. Please, are you following? Okay. Where's my marker? I know, just start. Oh, yeah, I put this in my phone. No, they can just ask you to find it. Okay, I will. I should go over. Okay, they can just normally this is too cheap for them to ask. You understand? They cannot ask you to derive the Laplace of a constant. They can ask you sine, kt, all those sine, cos. They can ask you those ones, but they can never ask you. And if it is taking because there's my don't be serious here. There's my answer can never ask this. You get So even all these derivations sef, if we ask maybe all those sin kt or kt, but we no ask this one. And if we want to test, you guys, we will not just give you Laplace of theory, you can combine it with cos theta, sin theta, all those things. So you just combine in such a way that it look complex, you get. But we never ask you to find the all derived Laplace of a constant. This is too cheap, you get. From this page, I said once you take the limits you get of x tends to 0 from this page, so if your x tends to 0, automatically everything will be 0, you get. So because normally if you are taking the limit to be 0, this one like this you leave it to just this exponential that I am considering. So if you now put 0 here, you get no 0 times infinity will still be 0, abi. So exponential 0 will be 1, right? Okay, sorry. If you take the limit, we are talking of limits, not just substituting. So if you take the limit, you are going to have something like this: 1 over s exponential minus s times what? Infinity, right? So you take the limit of s tends to what? S tends to 0. Now what will you do here? Simple thing. If you look at this, you see that if you put 0 here, this everything will be 0. If you put 0 here, you are going to have 0 by 0. 0 by 0 will give you infinity again. No. So you can now, what we do here, we differentiate, we use a L'Hopital rule, but you don't need that. Don't say that anytime you have infinity, I take the limit to x tends to 0, it's going to give you 0. But by the time you differentiate first, at the end of the day, you are going to have 0. So that will be long. So that's why I just note this. So that's the first one. So we are going to solve question on that soon. So the second one we will take into consideration is t function f of t equals to t. Yes, we are taking the constants, right? So there are some functions that they will not be in time domain. They will just use t as their symbol, like t, but it's not time domain. So they are having t. So let's see what we are going to have. Is that following? Now from this place, I'm still using my general formula. The Laplace of t equals to integral from 0 to infinity. Function of t is what? T, right? Exponential minus what? St the what? dt. Now from this place, what am I going to do here? This t, this exponential minus st, what am I going to do? Which integration is this? Integration by parts. This integration by parts. This is not a constant. So this integration by parts. You get? How do you solve integration by parts? Integration by parts is what? Integral of v du equals to what? uv minus what? Integral of what? No. Integral of u dv equals to what? uv minus integral of what? v du. That's what integration by parts is. So it means you have to choose your what? U. You have to choose your what? V from this place. Now, all you choose as your U and V. There are some conditions. There are like 3 conditions to choose your U and V. Go and check K-Stud, engineering mathematics, ordinary engineering mathematics. You see the conditions, 3 conditions to choose your U and what? And V. You are doing integration by parts. Are you getting? So I'll not be listing the 3 conditions, but just go and check ordinary engineering maths, K-Stud, you see it there. Now, you are having T, you are having U. I will choose this one as my U because part of the condition is that if you want to choose your U, let's say I have S now, S squared, and I have exponential 2x. I know that if I differentiate this one, S squared, first time, I differentiate it second time, it's going to elapse. Now I'm not going to see the x again. You understand? So once you know that, okay, part of the variable is that when you differentiate maybe once, twice or twice, you are not going to see the s again. That's one you are going to choose for what u. So that's part of the condition. So there are other two conditions too. So for this one now, I know that if I differentiate t, I'm not going to see the t at the end of the day, right? So I'm now going to say, okay, this is my u, and this u dv, right? So my dv will be equal to what? Exponential minus what? st. Are you following? So u dv, you see, integration by parts is just like opposite of differentiation of product rule. You know, product rule, they are going to have two of a function multiplying each other, right? So the differentiation of product rule, the opposite is the integration by parts. Because you have t times what? Exponential minus t. You have two things multiplying each other. So integration by parts is just the opposite of what? Differentiation of what? Product rule. So from this place, I'm going to have, I already know my u, I need to know my v, right? I need to know my v, because I don't know my v here. It's the v that I know. You know the v, but I need to know my v. So from this way, I need to know my what? The u as well. So what will be our du? Our du dt with what? Du dt with what? 1. So what will be our v from this place? All we need to get your v. You integrate, integration of dv equals to integration of exponential minus st. So what is integration of dv? What is integration of dv? What is integration of dv? V. Integration of dy is what? Y. So integration of dv is what? V equals to, so integration of exponential minus st is what? 1 over minus s, right? Exponential minus st. So you already know your du, you already know your v. Now let's continue. From this place, if you cross multiply du over dt equals to 1, if you cross multiply du will be equal to what? Dt. I mean, du will be equal to dt. Is that not? Then v equals to what? Minus 1 over s exponential minus what? St. Now come and put it here in your formula. So your Laplace of t is equal to uv, what are u? U is what? T, I mean, what is our v? Minus 1 over s, right? Exponential minus what? St, right? I'm still following the formula. Minus integral of, what is our v? Minus 1 over s, right? Exponential minus st multiplied by du. What is our du? Du is what? dt. Du is dt, right? Now from this place, I'm going to have the Laplace of t is equal to t times minus 1. You have minus t over what? S, right? Exponential minus what? St. This minus, take it out. So minus times minus, you have what? You have plus. Then integral of what? 1 over s exponential minus st the what? The t. Now you can see that this is simple now. You are just integrating in exponential minus st with respect to what? T only. Because 1 over s, does it have t? No, it's like a constant. You take it out. So you are going to have something like this. The Laplace of t equals to minus t over s exponential minus st plus 1 over s. You take it out. Integral of exponential minus st dt. So now integrate exponential minus st again with respect to t. So you have minus t over s exponential minus st, right? Plus 1 over s. So if you integrate this one, you're going to have what? Minus 1 over s exponential what? Minus st. So we are having our 0 to infinity, right? So we are supposed to put it here. Okay. Where are you supposed to put it? Right? 0 infinity. uv minus integral of, yeah, you are correct. So from this place, what are you going to have? You are going to have minus t over what? S. Exponential what? Minus st, right? Plus what? Minus 1 times minus 1. 1 times 1 is 1. S times s, s square. Exponential what? Minus st, right? And what do you have? 0 to what? Infinity. From this place, let's see what we are going to have. Let's see what we are going to have. Okay. You can split using the infinity, right? So you have minus t over s, exponential minus st, sorry, minus s. What's our s? Infinity bar? Infinity times what? Times t, right? Then minus 1 over s square, exponential what? Minus infinity, right? Times what? 0. Please, are you following? Are you following? You are not following. We are just trying to split. Do you understand to this point? Do you understand to this point? Okay. Where? Do you understand to this point? So why do you lose? You can't lose from the beginning. I told you you should call me back. Okay. Why? No, it's not the t that having the 0 now. It's the integration. 0 to infinity. Our u is t, our v is this, our dv is this. This. That's why I said anything you are doing in chemical engineering, don't just mistake forget. You have problem. The problem you have is that you need to go back. You see how you are doing now is what? Integration by parts, which you have done in your what? Other level math 121. Right? That's what you are doing. Just integration by parts. In your calculus, other level. So I think we have not forget the integration by parts very well. Sincerely, this is highly straightforward. But let me explain. I tell you go to t, and our dv is what? Exponential minus t, because your integration by parts says what? Integration by parts says integral of v du equals to what? Uv, integral of u dv equals to what? Uv minus integral of what? V du. Let me check this. Everyone will be on. Go. Alright. So now our u is t. When you differentiate the u dt, what are you going to have? The u dt is what? 1 abi? And when you cross multiply the u will be equal to what? 1 times dt, abi? So the u equals to dt. That's what you have there. Then for you to get your v from this place, you need to integrate. But you're having the v. You need to integrate both sides. For you to get your v that you are looking for, which is in your formula, v. Because in your formula, what you need to substitute is v, not the v. You understand? So you need to do what? You need to integrate. So when you integrate the v, you have v. It's like you integrating the y. If you integrate the y, it's equals to what? Y. You get? So now, if you integrate the v, you have v. You now integrate exponential minus st based on this explanation that I've done. You get? You have what? 1 over minus s exponential what? Minus st. Are you following? So the same thing. I just repeat it here. 1 over minus s is the same thing as minus 1 over s. Now put it in your formula. What is our formula? Uv. Have you? So what's your u? Ask yourself, what's your u? See now, that's what I put. What's our v? V is that, have you? I put it. Minus, continue with the formula. Integral of what? V du, right? What's our v? This, I repeat it. What's our du? Have you? What's our du what? Is equal to what? dt. That's why we put dt there. So now, I use this one to multiply t times minus 1 minus t over s exponential this. This minus, I take it out. You use the minus to multiply this. You have what? Plus. So minus times minus plus. So you repeat 1 over s exponential minus st dt. So you can now see that this is homogeneous now. T with respect to what? T dt. So you just take this 1 over s out because it doesn't have t. It has a constant. So you take it out, you integrate exponential what? Minus st with respect to what? Dt. and we do the same. You repeat this, write it down like this. This 1 over s is here. Then exponential minus st. When you integrate this one again with respect to t, based on this explanation that I have done, you have this. But you recall that your integration generally from the beginning, you must have your limit to be 0 and what? Infinity. So at the end of the day, since you have got all your integration, you put it there. So from this place, we are now going to split. You see these two like this, these two like this. You first put infinity. You now say minus. These two again, you put what? 0. So now from this place, you are going to have minus t over s exponential minus okay, instead of t, we are having t here minus what's our t? Infinity over s exponential minus what's our t? Infinity then you write this one also minus 1 over s square exponential minus s times infinity, right? This is the first one. Now say minus, right? The same thing, you have to 0. Minus 0 over s, right? Exponential minus s times 0. Then minus, because you have minus between them. 1 over s square exponential minus s times what? 0. Right, following? So automatically, you know that when you take the limit of everything that is having infinity here, everything is what? 0. You get? Take the limit of everything here. So everything here like this is what? 0. Then minus this one like this. 0 over s is what? 0. 0 times everything is what? 0. So you still having 0. Look at this. This minus is also affecting this, right? So minus times minus plus 1 over s square times exponential minus s times 0 is what? 0. Exponential 0 is what? 1. So you are having 1. So 0 minus 0, that has gone, 1 over s square times 1. 1 over what? S square. So that means the Laplace of t is equal to what? 1 over s square. Please, any question? If you have any question, please ask. And if you have another idea, maybe shortcut, just bring it. That's what I always do. Because most of our days we have past question. I always solve past question solution. It's because you have not seen it. I have my past question solution. That I always do for 211, 411, 511. So what I do is that I will look at 5 years back. I will now solve both test and exam questions. So it's not only me. Most of the people that I know in our class, I have the idea. How far? Me, I have solved this. This is my best way of solving it. What's your own best way of solving it? So you give me and now compare and bring out, the best out of the two. So that's how you always do. So if you are solving anything here, and you have the best way that you can get it, just share. Possible, I can get from you as well. Yes. Alright. Okay. This one. So how I choose you and I said it's part of the conditions. So if you want to know the conditions to choose U and the V under integration by parts, just go to KH Storage, ordinary AG math. There are 3 conditions there. They list it out. If you are reading out integration by parts in KH Storage, you see it there. You understand? So, and I said the reason why I choose this is that I have known that automatically if I differentiate this T either once, twice, the T is going to elapse. I'm not going to see the T at the end of the day. When you say the U, the T, what do I have? 1. Do I have T again at the end of the day? No. Automatically that will be your U. So if T is now your U, so what will be this one? The V. So don't just say this one is U and this one is V in integration by part. No, that is under product rule. It's under product rule that I say this is U, this is V. In integration by part, you choose one as your U, the second one as what? The V. Because the formula says U dV equals to what? uv minus integral of what? V du. So that's why you need u, you choose u, you choose what? dv. You can ask question. You now integrate. Yes, once you choose your dv, yes, you now integrate that dv to get your v. So after I choose dv equals to this, and I know that in my this thing, I need what? V there. So once you now get v from dv, you now integrate it. So you get your v. So if you now get your dv, you just differentiate your so that's another function. So before I move to Laplace of exponential e raised to power at, let me do, because I've done Laplace of t, let me do Laplace of t raised to power n. You get? So I now do Laplace of e raised to power t. Please take this opportunity. What I can bet in no professor get time to dey explain like this. We have come class write notes for you, and so dem do am for us to in clear level. You get? No very it's even better. But my answer is better. It's better. But my answer will give you better notes now. It's better handwriting, abi? You never see one wey dey come class come say yaba which course are you taking? You never see one wey dey come class come ask you which course are you taking? You go soon see am. Function t raised to power n. So what if is not t? You know that t the power is 1, but what if the is not t raised to power n where n is greater than 1? You get? So you still go by your formula. The Laplace of t raised to power n equals to integral of 0 to infinity of t raised to power n exponential minus st dt. Yes. So from this place, if you are tired, just tell me. So the Laplace of t raised to power n is now equals to, what are you going to do here as well? Integration by parts, right? So where your u will be equal to what? T raised to power n, right? So our u will be equal to t raised to power n, then dv equals to exponential minus st. So our du dt will be equal to what? N, t raised to power n minus 1. Then our v will now be what? Minus 1 over s exponential minus st. You get? So cross multiply to get your du. Du will be equal to what? Nt raised to power n minus 1 dt. And then you have your v to be minus 1 over s exponential minus st. So now use your formula. The formula says uv minus integration of what? V du. So you now have Laplace of t raised to power n equals to uv. What's our u? T raised to power n multiplied by what's our v? Minus 1 over s exponential minus st minus, right? Integral of v minus 1 over s exponential minus st du. What are du? Du is what? N c raised to power n minus 1 dt. I believe you all know quantification and combination, right? So from this place, you are going to have minus 1 times this one. You are going to have minus t raised to power n, right? Over s. Are you following? Exponential minus what? St. This minus with minus, take it out. You have what? Plus, have you? Integral. Just put your 0 to infinity. Oh, sorry. Don't put it here. 1 over s, right? Exponential minus what? St. Dot nt raised to power n minus 1 dt. You know that this n, I can take it out. This n. Or this n and 1 over s, I can take both of them out, right? I can have something like this. The Laplace of t raised to power n equals to minus t raised to power n over s, right? Exponential minus st plus n over s, right? This n and 1 over s, I take it out. N over s. Integral of what? Exponential minus st t raised to power n minus 1, right? dt. You can see that at this point, you are still having two functions multiplying what? Each other. You see, going to use integration by part again. Now, from this place, you are going to have what? You are going to have, let's keep this aside, n over s aside as well. So, you are going to have minus t raised to power n over s exponential minus st plus n over s, open brackets. I'm going to be integrating direct. My integration says what? uv minus what? Integral of what? v du. Is that not? Now from this place, where is my u? My u is t raised to power n minus 1. I'm doing it direct. I don't want to be saying u equals to something, the v equals to something. Just cope with it. My u will be t raised to power what? N minus 1. Abi? And the v will be e raised to power minus what? St. So uv, so u is t raised to power n minus 1. Dot v, you know this is the v, so we are going to get it. We are going to have what? Minus 1 over s exponential minus st. That's the uv minus integral of v du, right? So v is still the same thing as this bar, minus 1 over s e raised to power minus st du. Now if this one is u, what will be your du? It's going to be n minus 1, right? T raised to power n minus what? 2. Is that not? That will be your du. Then you are going to have dt with it because it's going to be du over dt, right? You are going to have dt. So this is what you have. Now let's simplify it. You see what we are going to have now. Minus t raised to power n over s exponential minus st plus n over s into, so if you multiply here, you are going to have what? Minus t raised to power n minus 1 over what? S, right? Exponential minus st. Take the minus out, you are going to have what? Loss, right? Take the n minus 1 out with s, you are going to have n minus 1 over what? S. Integral of, is it minus or plus? It's plus, right? Exponential minus st t raised to power n minus 2 dt. This is what you have. Now from this place, you can see that by continuous integration, look at it. By continuous integration, this your, okay, I'm coming. I want to open this bracket with this n over s. Look at what we are going to have. Before I explain what I want to explain, minus t raised to power n over s exponential minus st. N times this, you are going to have what? Minus nt raised to power n minus 1 over s square, right? Plus n open bracket n minus 1, right? Over what? S times s, you have what? S square, right? integral of what? Exponential minus st t raised to power n minus 2 dt. You can see that by continuous integration, what is happening to your t? If you look at this from this way, t raised to power n, it reduces by what? By 1. Here is also reduced by what? By 1. By 1 now, it's reducing by 1. That's the meaning. Then, if you look at this, your s is what? It increases by 1 because this actually s, this is actually what? S squared. Do you know that? It increases by 1. So that means you can now conclude based on permutation and combination that the Laplace of t raised to power n is same thing as what? Okay, I want to generalize the formula from this page. This one is decreasing by what? By 1, right? Okay, it's now the n factorial. Thank you. Because if you look at this, n from n to n open bracket what? N minus 1. Abi? So it means we are having 5. Here is, let's say here is 5. And here is now 5 open bracket what? 5 minus 1. Abi? Because the next one will now be 5 into what? 5 into 5 minus what? 2. If you still integrate this one, that will be the next one. So if you look at this, it's n factorial from the permutation and combination over. If you look at this s now, it's going to be s raised to power n plus what? Plus 1. It's now increasing by what? By 1. So that's your Laplace of t raised to power n. So you don't need to continue your integration. Well, you're still going to have at the end of the day s raised to power 3. This one s raised to power e raised to power s minus t raised to power n minus 3. That's what you are going to have at the end of the day if you still integrate this one. So you don't need to continue like that. You can just now generalize it that okay, the increment for n is in form of n factorial. You get? Then s is increasing by what? By 1. So that's your answer. Okay. So please, anytime you have to derive this, after you have done the second derivative, just write the word. You have to put it in word. Most of textbook self, you always put this something like this in word. By the factor of the integration by parts, you get it is continuous. That means it can be generalized that the n is decreasing by 1 and the s is what? Increasing by the power of 1. You get? So you can now write it in factorial form. So we have done how many Laplace? We have done 3 down. So let's move to the number 4, which is exponential at. Can I play this?
Smart people, you have to put the content. Smart people.
Can we continue? Okay, I have questions. Okay, yeah. Okay. Yeah. Okay, thank you. Yeah, I'm supposed to put exponential minus st here. Yeah, this one times this. Yeah, thank you. I can clear this one now, right? So let's see another Laplace. 4, right? Function of exponential at. Function of exponential at. Do you believe that when we were in TLL, we didn't do Laplace? It was part of the course notes, but they didn't teach us. And they set it in our exam. They set it, but they didn't teach us. But thank God, sha, it's number 6. I didn't even do it. It was after our exam that I learned it. Which what everybody was shocked that you already told us that since you know teach us, so it will not come out. So we didn't even put attention. We put attention on differential equations, Fourier series, which again, all these eigenvalues and eigenvectors matrices. So then we go see Laplace transform. I didn't even do it. It's early. So that was what affected most of us in 500 level. It affected us very well when we were doing process control. But most people didn't know it that time, you understand? So they had to learn it again before they now know the process control. So let's solve this. The Laplace of exponential at will be equal to what? Integral of what? 0, right? To infinity. Exponential at dot what? Exponential minus st the what? The t. So this indices bar. Is that not indices? Yes. So you can just have integral from 0 to infinity. Take one exponent, right? You have at minus st, right? The t. Are you following? So this one can now be integral from 0 to infinity. I can write this if I like. I can write it as minus st plus at. Is that not the same thing? At minus st is the same thing as minus st plus at. Minus 2 plus 3 is the same thing as 3 minus 2. So now from this place, 0 to infinity, exponential, what is common? No, not only t. No, minus, thank you. Minus is common, t is common, right? Then open bracket, s, minus a dt. It's common now. How many minus do you have in plus? How many minus do you have in plus? I have a minus here. Is minus not common? So from this place, I can have integral from 0 to infinity, exponential, this thing like this, that's outside here. I can take it to this place by saying exponential minus open bracket s minus at dt. Is it not the same thing? Uh-huh. Now from this place, you can now integrate. If you integrate exponential open bracket minus s minus open bracket s minus a, right? So what is beside t? You are having open bracket minus what? S minus a. That's everything beside what? T. So you are not going to have it as what? E exponential what? At minus what? 1 over s minus a. Thank you. Exponential what? S minus a. Oh, sorry. Minus, right? S minus a t. S minus a t. That's all. Is that not? Then you put your limit 0 to what? Infinity. Now from this place, you are going to have minus 1 over SA, or let me take the minus 1 over SA out. You get, because it doesn't have anything like t. Is that not? Minus 1 over SA, then open bracket exponential minus s minus a t 0 to infinity. So this one doesn't have anything like t, so I'm not going to put the limit there. Now from this place, I'm going to have minus 1 over s minus a. So for this one, I put infinity. You have exponential minus open bracket s minus a times infinity, right? Minus exponential minus open bracket what? S minus a times what? 0. Now from this page, you are going to have minus 1 over s minus a into, take the limit of everything here, you have what? 0 minus everything else what? 1. So you are going to have minus 1 over s minus a times minus 1. So minus times minus is also plus, that's plus 1, right? And hence you have 1 over s minus a. So that is your Laplace of what? Exponential at. So provide that s is greater than what? A. 1 over s minus a. So a is your constant. It can be any number 2, 3, 4. So okay. No, it's not a must. It's not a must. You do it the way it's convenient to you. This is the way it's convenient to me. You understand that? So, what if it is Laplace of exponential minus 80? One over s plus a, thank you. 1 over s plus a. It's part of the general formula now. The general formula is f of t exponential minus st, right? dt. So let me write this one very well so that it won't look like 8. So you just think that it's 8. So we have done 4, right? So we are going to do, it remains 4. Sin 80 cos 80 sin h 80 cos h 80. Sin h 80 cos h 80. You can also call it sash. Well, me, I don't like to call it like that. I don't get too much. I don't get 36 or 32 this thing. You just call it sin h. Sin h 80. Are you following? So all these things that we are deriving like this, how will it help you? You know that if you know mathematics normally, you will derive it. You understand? So how will it now help you when you are doing exam? It's by cramming them. Normally they ask you to derive them, you can derive them now, normal. But if you need it urgently, without derivation or something, you understand? You can't just carry your book and be deriving again. You just have to cram Laplace of a constant. This is what it's going to be. Laplace of t, Laplace of t raised to power n, Laplace of e raised to power at, Laplace of e raised to power minus at, Laplace of sin k. All those things you cram them. You get? Oh, sorry. Okay, I should write it back. So what do I have there? Laplace of exponential what? At, right? Equals to, I think, minus 1 over SA exponential minus. Something like this, right? I think you are happy now. You know how you put out and say, don't punch me. Okay, so sin 80 sin 80. Shall I continue? Okay. So from this page we are going to have Laplace of sin 80 equals to integral from 0 to infinity of what? Of sin 80 exponential minus what? ST. Now, if you want to do the integration of this, there are two ways that they always use. The first one is by complex method. You know, integration by complex method. We have done that in 12 level in GMAT. Integration by complex method, or we use integration by parts. You get? So I will use by part for you. You get? So I will use by part for you. If you want to learn, don't worry. If you want to learn complex method, just hit me up to pro. I will do video on that. I post on my pages. I have pages because I have not told you. So I have pages, my tutorial pages. So you go and follow my pages. You get? So then, even if we are not, even if not this easy match, if it's transfer phenomenon, any course, any chemical engineering course you want me to take, just hit me up. I just do video on it, post on my page. Then you download. You get? So because I think after today, I'm not going to have time again. So what do you say? I know I don't have time again. No, don't meet me. Just go and watch my page. Just follow up my page. Hit me up on WhatsApp. Say make I explain one course or something. Don't worry, I will write it. So I just do video, then you see it on my page. Then you download any course. You understand? So don't say because I will post this one, you now leave here. You leave here, there are some explanations that I will do here, or there are some hints. You know, when I started, I have not on the camera, and there are some important things that I said. So that's the advantage of physical class. There are some things that I will say that I will off the camera. So not to implicate my personality, you get. So let's continue. I will use integration by parts here today. What way are you? Are you the sin 80? And the v will be equal to what? Exponential minus st. So you want to follow up my pages, all social media, Facebook, YouTube, specifically YouTube, because all videos like this, I can't be posting them on Facebook, TikTok, Instagram. No, it's just short videos I do on the YouTube. You get? So I do long videos on YouTube. So just follow up Laurent Bashir tutorials. Tutorials. These are how I write it. Bashir tutorials. So from this place, my du will be equal to what? Du dt. If you differentiate sin 80, what are you going to have? A cos 80. Thank you. A cos 80. We have to differentiate sin 2x. Are you going to say cos 2x? No, now. You say 2 cos 2x. So sin 80 is what? A cos 80. So if I put a here, what I'm telling you directly is that that a is greater than 1. That's the meaning. Because if the a is not greater than 1, I'm not going to put the a, I'll just put sin t. Is that not? Then your v will be equal to what? Minus 1 over what? S exponential minus st. Now, we are going to have the Laplace of sin 80 equals to uv, right? So what are u? Sin 80 back. Dot what are v? Minus 1 over s exponential minus st minus integral of v. What are v? What are v? Minus 1 over s exponential minus st. The u dt. What are the u dt? Dot a cos 80. A cos 80 dt. What is the u? Now from this place, yes, because the formula is du. Is that not? uv minus integral of v du. So for you to get your du here, you cross multiply now. So there will be u will be equal to a cos 80 d what? dt. Are you following? So from this place, I'm going to have minus what? Sin 80 minus sin 80 over s exponential minus st, right? Plus, right? A over s. Is that not? Integral of what? Exponential minus what? St cos what? Cos 80 dt. Please, are you following? Okay. Look at this. Minus sin 80 over s. Are you? Exponential minus st. Are you following? Then I take this a and 1 over s. I take it out. So I have this minus and this minus. It becomes what? So I have a over s, right? The integral of this exponential minus st. I repeat the same thing. Then cos 80. Now I'm taking the a out. So I have cos 80. Then dt. I bring out it because they don't have t. You know, s doesn't have t. A doesn't have t. This a beside cos. It doesn't have t now. And so it will not affect the integration we want to do next. You understand? That's why you bring it out. This a like this that you are seeing is like maybe 2. And this s that you are seeing is like maybe 4. So they are like constant. Just take it out. You get that? So from this place, that's what I'm going to do. I'm going to integrate this again. This one, it has a particular trick, but it's not something that you know understand. You understand it. The trick is this. Let's continue. Sin 80 equals to minus sin 80 over what? Over s exponential what? Minus st, right? Plus a over s. Open a bracket. Now let's integrate this one again. But I'm not going to be writing u is this, the v is this. I'm just going to do it direct. Now from this place, look at what I want to do. Our u is what? Cos 80 bar. So you write it cos 80 dot v is what? This. You are integrate this, right? To be minus 1 over x exponential minus st. I'm still using integration by parts. Then minus integral of what? V du abi. Also what are v? Minus abi 1 over x exponential minus st. And then du. So what we are du? Minus what? A sine 80. Thank you. Minus A sine what? 80 d what? dt. Aha. Is there integral there? Okay, there is integral, yeah. Now look at this. We are having the Laplace of sine 80. I'm having, look at this. From the beginning, the Laplace of sine 80 is given by what? Sine 80 exponential what? Minus what? st d what? dt. Now let's see something here. The Laplace of sine 80 will now be equal to minus what? Sine 80 over what? Over s exponential minus st plus a over s into minus times this. You have minus what? Cos 80 over what? S exponential what? Minus st. Is that following? I'm just opening the brackets. This a over s, I write it again. Then your cos 80 times minus 1 over s. Cos 80 times minus 1. You have minus cos 80 over s exponential what? Minus what? st, have you? So it's still the same thing. Then you have minus integral. Look at this. This is minus. This is also what? Minus. Minus times minus, you have what? Plus now, have you? Minus times minus, you have plus. This 1 over s. This is also what? A. You know I can take it out. I can have it like minus a over s, right? Sine 80 exponential minus st dt. It's minus, take it. It's minus. It's not plus because it's only this one and this one that will multiply. This minus 3 remains there. So I just take this a and 1 over s, I take it out. So I have a over s. Then exponential minus st with your sine 80, I combine it. I just bring the sine 80 before exponential minus st. Now look at this. What is, look at this integration. Integration of sine 80 exponential minus st dt. What is it from the beginning? Laplace of what? Sine 80. So instead of that, I will repeat. Laplace of sine 80 equals to minus sine 80 over s exponential minus st plus a over s, right? Into what? Minus cos what? 80 over s exponential minus st minus a over s Laplace of what? Sine 80. So check. Where do you have any question? You understand how I choose my u? You understand how I choose my degree here, right? You know how you differentiate this, right? The u over the t. What is the differentiation of sine 80? A cos 80. Then what are you going to do here? You have been doing this so far, right? Now you get this. And just put it. We are using integration by parts, right? So integration by parts says uv. These are u. V. This sine 80. Your v is this. Minus integral of v du. What are v? V is this, right? Then du with t is this. But what you need in your formula is du. That is you have to cross multiply to get your du. So your du is this. That's what we put here. Now from this place, we have minus sine 80, right? over s. When you multiply this sine a3 with minus 1 over s, you have this. Then you have exponential minus st. This is minus times minus plus, you have it outside. A over s, you take it here like this. Then you have your cos at with your exponential minus what? Minus st. So look at this again. It resembles what? It resembles integration by parts. So this integration like this, you see we do it as what? Integration by what? By parts. So that's how we treat it like that. So this will be your u, right? And this will be your what? dv. Are you following? This will be your u and this will be your dv. So if you differentiate, okay, from the formula we have uv. U is what? Cos at, right? Then this is your dv. So you differentiate it, you integrate it to get your what? V. You have this. Then minus integral of v du. So your v is this. You repeat it. Du is, when you differentiate this, when you differentiate cos 80, you are going to have minus a sine 80. And you have your dt. Because you are going to have du dt equals to minus a sine 80. When you cross multiply, you have your du to be minus a sine 80 dt. So you now open the bracket. This one we leave it like this. A over s is still there. Then cos 80 times minus 1 over s. That's why you have minus cos 80 over what? Over s. Exponential minus st. Right? This minus and this minus. When you multiply it, you are going to have what? Plus. That's why you have positive in the integration. This minus still remains there. This a, this s. Right? So a over s is still there. Right? So that's why you bring it out. You have your sine 80 exponential. Now from this place, you can recall from the beginning that your integral of sine 80 exponential what? St dt is Laplace of what? Sine 80. So instead of all this integration like this, instead of all this, you just put what? Laplace of what? Sine 80. So let's now see how we collect the right term to make our Laplace of sine 80 subject of formula. So let's see something. So Laplace of sine 80 equals to minus sine what? 80 over s exponential minus st. So we open the bracket, right? So a times minus cos 80, you are going to have minus what? A cos 80 over what? Over s square, right? Exponential minus st. A times a square. A times a, you have a square over s square. Laplace of what? Sine 80. Are you following? Now from this place, I can take this, what is it called? All this to the other side. So we are going to have Laplace of sine 80 plus a square over s square. Laplace of what? Sine 80. Everything equals to what? Minus sine what? 80 exponential minus st, right? Over s, right? Then minus what? A cos 80 over s square exponential what? Minus st. Now from this place, what are you going to do to get your s square at this place? You know this place can be, it's like over 1, right? S square. So 1 in s square, what do you have? 1 in s square. S square now. S square times Laplace of this, you have s square, Laplace of what? Sine 80. Plus s square in s square, 1, right? 1 times, you have a square, sine what? Sine 80, right? Sine 80. Laplace, right? Laplace of sine 80 equals to minus sine what? 80 exponential minus what? St over what? S, right? Minus a cos 80 exponential minus st over s square. So write this before we continue. Are you done? Now from this place, what are you going to do? You find the LCM at that right hand side, so you have your S square. So for this place, so you're going to have, well, let me factorize this. Laplace of sine 80, Laplace of sine 80 is common. I'm going to have Laplace of sine 80 into S square plus what? A square over what? S square, abi? Equals to, so what's LCM here? S square, abi? So how many S will you see in S? That's 1 over. So you're going to have minus S sine what? Sine 80, right? Exponential minus ST. S square in S square, 1. So 1 times A, we have A cos AT exponential minus ST. So S square, cancel S square, right? So we are left with what? Laplace of sine 80 into S square plus A square, right? Equals to minus what? Minus S sine what? 80 exponential what? Minus ST, minus A cos 80 exponential minus ST. Now, from this right hand side, you know all the integration that we have been doing, the first integration that we have done, we didn't take the limit of 0 to infinity, right? So here that you are having t now, because here you don't have anything except your Laplace of sine 80, which is Laplace. So you don't have anything function of t. So at this point now, let's take the limits. So let's put our 0 to infinity. We are going to have Laplace of sine 80 into S square plus A square equals to, now we have infinity, right? So I'm going to have minus S sine A times infinity, right? Exponential minus S times infinity minus A cos A what? Times what? Infinity exponential of minus S times infinity. That's the first one, right? Close the bracket. Minus S sine A times what? 0 exponential what? Minus what? S times 0, right? Minus A cos A times 0 exponential minus what? S times 0. Of course, you know that everything at this infinity will be what? 0. That one is gone. So we have Laplace of sine 80 into s square plus a square equals to, so everything is zero like this. So you are left with this one, you know, right? Which is sine zero is what? Zero, abi? So sine, if you say sine zero, you have zero, right? Sine zero is still zero. So everything here, you don't have it again, right? Now, cos zero is what? 1. Abi? Cos zero is 1. Exponential minus x times 0. X times 0 is still what? 0. Exponential of that is what? 1. So you are left with minus open bracket minus a times what? Cos 0 is what? Cos 0 is what? 1. So everything times 1 because this one will also be what? 1. So you are left with what? Laplace of sine 80 into s square plus what? A square minus times minus plus you have what? A. So for you to get to Laplace of sine 80 that you are looking for now, all you do is divide it by what? S square plus what? A square. So Laplace of sine 80 now equals to A over S square plus A square. Okay. If you have S over 2 equals to 4 over 2, what's the answer? Oh, I've answered you. See, I've answered you. If you have S over 2 equals to 4 over 2, what's the answer? S equals to what? Oh, it means that the 2 can cancel 2. S equals to 4. If you see both multiply, say 2 times S, 2s, 2 times 4, 8, you still divide over by 2. So S square can cancel S square. See there, it's equal sign. And also, you have already find the LCM. You understand? If you are not find the LCM now, you cannot cancel. Answer. Sure now? Yes. Don't worry, I will explain that through video. That's why I said you want to come and follow my page for that. I will explain that through my video. So you see it before Monday. So just follow my page. You see that the same thing. Any method you use between the two. Both are shorter. Both. Both are short. It's because I'm explaining. If I'm not explaining to you, I will have done now. But complex is easier. So both are shorter, but complex is easier. Just bring your e raised to power minus I theta equals to what? Cos theta plus I sin theta. That's what we will use. I will explain that through my video, don't worry. So that is sin 80 for you. If you want to do cos 80 through by part also, the same procedure. At the end of the day, instead of you representing your Laplace of sin 80 here to the Laplace of cos 80, you understand? Because when you do the second integration of that, you are going to have cos 80 exponential minus st, which is Laplace of what? Cos 80. You get that? So I'll just give you for cos 80, I will not derive that. The same procedure. Laplace of cos 80 will now be, instead of 8 will be s, you get, over s square plus what? A square. That's just difference. So it remains 2 for us to go. Can I move on? Okay, this place. Okay, yeah. Let's finish first. Are you done? Go now, so we want to go. Go now. Ah, that's the way you do in class. Huh? All right. So Laplace of that six, is it seven bar? Six. Okay. Laplace of sine eight eight eighty. Laplace of sine h80. So this is, we call this hyperbolic function. This hyperbolic function is called change. Change. So normally your what is it called? Normal hyperbolic function. Sine ht is what? Sine ht is what? In your hyperbolic function. What is sine ht? No, 1 over 2 exponential 80 minus what? Exponential minus what? 80. So this is your normal sine ht. So it's 1 over 2. So the 1 over 2 covers everything. It's like this. The 1 over 2 covers everything like this. So you can just 1 over 2 open brackets, something like that. So now also cos ht. Cos ht is what? Exponential what? 80 plus what? Exponential minus 80 over 2. So they are constant value you get, or expression. So sine 80 is same thing as this. Cos 80 is same thing as what? This. Now, no, that's not the final answer. Let's bring their, because you are not going to use this directly in your this thing. Now from this place, your Laplace of sine, so it means I'm not putting, let me just say sine ht. You get sine ht now equals to integral of what? 0 to what? Infinity. Or what is our function of t? Sine ht, right? Sine ht, exponential minus what? St dt. Are you following? Now from this place, I know that my sine ht is the same thing as what? Exponential what? At minus exponential what? Minus at over 2. Multiply by what? Exponential minus what? St dt. Are you following? Now from this place, this over 2 like this, I can take it out, right? To be 1 over 2 integral of 0 to infinity. This exponential minus st is actually multiplying both, right? So like something like this, exponential at times exponential minus st minus exponential minus at times exponential minus st all dt. So now from this place, you use your indices. You are going to have 1 over 2 integral of 0 to infinity. So if you multiply this one, you are going to have what? Exponential what? At minus st bar. And this one is minus exponential what? Minus at minus st, right? dt. Are you following? I can clean this place. Now from this place, I will have it as the Laplace of sine ht equals to 1 over what? 1 over 2. I can write it as minus st plus 80, right? Okay. Integral of minus st plus what? 80. Is that not? Then minus integral of minus st minus what? 80 dt. I will now factorize what is common. So what is common now? T bar. So we have 1 over 2 integral from 0 to infinity. So in exponential, what is common? T bar. So you can have it as minus is common as well. Minus s minus a, right? Then t, right? Minus exponential. Minus is common as well, abi? Then you have minus open bracket what? S plus what? A t dt. Thank you. Now from this place, I can write it as what now be the integration now? 1 over 2 integral of this one will be minus 1 over s minus a bar, right? Exponential what? Minus s minus a t. Then this one will be what? Minus will come to minus, right? This one will be what? Plus 1 over s plus a, right? Then exponential what? Minus s plus a t. 0 infinity. Is are you following? Now from this place I can have it as 1 over 2 open bracket for infinity. You know that automatically if this one is infinity, this one is infinity, both of them are what? 0. So I'm going to start with the minus. Please are you following? Or let me just do it one by one so that you get. You have 1 over 2 open a bracket, abi? Minus 1 over s minus a exponential minus s minus a times what? Infinity, right? Plus 1 over s plus a exponential minus open bracket s plus a times infinity. Then minus, right? Open bracket again. Minus 1 over what? S minus a exponential minus s minus a times what? 0 plus, right? 1 over s plus a exponential minus open bracket s plus a times what? 0. Is it clear? So you know that this and this, you take the limit, they are both what? 0, right? So you are left with only this one. So exponential everything equal to 0 Is it the same thing as 1, abi? Exponentiality equals to 0 is the same thing as what? 1. So you are going to have 1 over 2, open a bracket. So you are left with what? This is minus, right? So minus times minus, you have plus, abi? You have 1 over s minus a. Then minus times plus, you have what? Minus, right? You have minus 1 over what? S plus a. Then what are you going to do here? In this bracket, what are you going to do? To find the SM now. So the SM will be what? S minus a, S plus a. So S minus a and S plus a. You have S plus a back. So you have S plus a minus S plus a and S plus a. You have what? Open bracket S minus what? A. But you know that the 1 over 2 is still there, right? So open the bracket. You are going to have 1 over 2 s plus a minus times s minus s minus times minus a plus a, right? Divided by what is this one? This one is what? Difference of what? 2 squares, right? So s times s, you have s squared minus as plus as minus a square, right? So we are going to have s squared minus a squared. S minus a into s plus a is what? Difference of 2 square, huh? Find the LCM here. Yeah. You know that this one has 0 already. We are left with this. So this, you have a minus. Everything raised to power 0 will be what? 1 now. Everything raised to power 0 will be what? 1. So we are left with minus 1 over sa plus 1 over sa. So minus times minus plus, that's why you have 1 over sa. Minus times plus minus, that's why you have minus 1 over sa. So you now find the LCM here. You know that 1 over 2 is outside, right? So now from this place, s can cancel what? Is it s that will cancel? No, it's not s. It's a that will cancel, right? Plus a, how will cancel? It's s now, I'm correct. It's s plus a minus s plus a, right? S cancel s, right? So we are left with what? 2a, right? 1 over 2 into what? 2a over what? S squared minus what? A squared. 2 cancel 2. So you are left with what? A over s squared minus a squared. So the Laplace of sin ht is what? A over s squared minus what? S a squared. Okay. H T. Is that to do what? Yeah, ba? Yeah. Sin H80, yes. H80. It costs H80. H80. So the same procedure for what? Cos H80, you understand? The same procedure like this. At the end of the day, you are still going to have something like this. You open the bracket, find the LCM, cancel 2. So when you do for Laplace of cos H80, you are going to have, instead of a, you are going to have what? S over s squared minus a squared. When you do it very well, using the same method, you are going to get it. Is are you following? So if you have known all this derivation very well, at least let me say you are 50% done with what you want to know in Laplace. Now, yes, 50%. So now the remaining 50% is your inverse. How do you do Laplace inverse? All these things that we have done now, all these derivation that I have done, the final answer, you need to know how to use them to solve questions, and that's what I will do for you today. I'm not going to do Laplace inverse, and I'm not going to do how to use Laplace to solve differential equation. I'm going to do the video on that for you later, but not today. How to use Laplace to solve differential equation. To solve differential equation. Differential equations. So after all this, these are the two important things. In fact, this last one is most important, because there's no how you want to do in your test and exam. You see a differential equation whereby they ask you to use Laplace to solve it. You understand? So that should be your target. So all this one is not that they are not your target, but the main thing is here. What if they give you maybe two questions under differential equation, use Laplace? At least two questions might be maybe they might give you one, use Laplace. They will now give you maybe short one out of all this one. They can say what is Laplace of exponential TDT. You understand? Another one is short, they will put 7 marks. Another one, they might put 8 marks. That's 15 marks for you. Well, I know Manasi never set one question and give you 15 marks direct. It can never be possible. You dey dream. So you make sure that you solve tire before you attain that 15 marks. So, but don't worry. Just make sure that you always reach out to me. My problem is that if you don't reach out, I don't know that you have problem. That's it. So, but if you reach out, even if it's not only engine math, your transfer phenomenon, your chemical kinetics, your separation process. What are you doing in separation process now? Separation process. Separation process. What do you separate the heat transfer? Mass transfer. That's transfer phenomenon. Transfer phenomenon is divided into three: mass transfer, heat transfer, and energy transfer. It's under transfer phenomenon. It's not under separation. Who is taking you? Let me see what you are doing. Let me attend to something. I'll be back. Okay, no problem. Fixed law of molecular transport, and you are saying separation process. This is transfer phenomenon. No, now this is transfer phenomenon. Fixed law is another transfer phenomenon. It's not separation. Separation is like all this your secondary school separation techniques. It's just boost it, separation process. What you are going to be doing here are distillation, evaporation, chromatography. These are the things you'll be doing. They don't change things for you. Transfer phenomenon, you do mass transfer. First transfer phenomenon you do TP1 is mass transfer. When you reach second semester, you do momentum transfer. That's when you be doing falling films, annulus, flow in annulus. That's second semester. When you reach one level, you do heat transfer in your transfer phenomenon. If you ask one level today, what are you doing in transfer phenomenon? You there? Imagine. Wow. You don't start everything. See the problem you are facing now in chemical. Up.